Hi everyone! In this video we are going to discuss isomers and different types of structures that we can draw. So isomers are compounds that have identical molecular formulas, but they have a different arrangement for their atoms. So structural isomers are a type of what's called isomerism, in which the atoms bond in different patterns. So down below you can see two different structures that have the same exact molecular formula, which is C2H6O. So each of those compounds below has 2 carbons, 6 hydrogens, and 1 oxygen. But depending on where each of those atoms are in relation to each other, we can end up with different structural isomers. So the first one is called ethyl alcohol, and we'll learn how to name compounds later, so don't worry about the name. But we have 2 carbons right next to each other, and each of them has enough hydrogens to give them 4 bonds. But the second carbon is also bonded to an oxygen, which will be bonded again to a hydrogen. Then, if we look at the other compound, dimethyl ether, we have a carbon, then an oxygen, and then a carbon. So this time the oxygen is in between the 2 carbons, and we get completely different compounds with completely different physical properties, even though they have the same number of each type of atom. So for example, ethyl alcohol, the first structure, is a liquid at room temperature and completely soluble in water. But dimethyl ether is a gas at room temperature and only partially soluble in water. So if the arrangement of atoms is different enough, you can end up with completely different properties. So let's practice drawing structural isomers, and this time we'll do this for a molecule, or molecules, I should say, that have 4 carbons and 10 hydrogens. So I'll just get you started here. Let's start by just drawing 4 carbons in a line. So we'll just draw 4 carbons all bonded together in a chain. And then let's add enough hydrogens that each carbon has 4 total bonds. So the carbon on the left-hand side needs 3 more bonds to give it a total of 4. And we're just going to add hydrogens there. The next carbon already has 2 bonds, so it needs 2 more bonds. And we'll just add some hydrogens there. And then the other side will be the same. So this is a symmetrical molecule. And let's just count our hydrogens to make sure that we have the right number. So there's 3 plus 2, which is 5, plus 2 is 7, plus 3 is 10. So we've got 10 hydrogens. Perfect. Now, is there any other way that we could arrange these atoms? So see if you can figure out a structural isomer for C4H10. And you can pause the video, and then when you're done, we'll go over it together. Okay, so one potential structure that we could draw here, maybe we have 3 carbons in a line, and one of the last carbon maybe is connected to that central carbon. So this would be what's called a branched alkane. So we've got a little branch coming off of our main chain of carbons. All right, now let's add enough hydrogens to each carbon to give them 4 total bonds. So again, the one on the left would get 3 hydrogens. And now let's look at the carbon in the middle. It already has 3 bonds, so it just needs 1 more. Okay. And then the carbon on the other end needs 3 bonds to make a total of 4, so that will be all of our hydrogens there. And then the carbon that's coming off of the middle carbon, it only has 1 bond, so it needs 3 more. Okay, and let's just count our hydrogens and make sure we have enough. So we've got 3 plus 3 plus 3 plus 1, so that gives us 10. Perfect. So these two structures are isomers of each other because even though they both have 4 carbons and 10 hydrogens, they have different arrangements for their atoms. So the structure on the top is called butane. The structure on the bottom is called 2-methyl propane. So these are completely different molecules. And again, don't worry about the naming. We'll learn all about that later. Okay, now is there any other way that we could have arranged these? Nope. Now, if you were thinking, what if we drew them in a square? So what if we made a ring? Well, unfortunately, to do that, we'd have to get rid of 2 hydrogens. So each carbon would have 2 hydrogens on it to make a total of 4 bonds for each carbon. And then we'd only have 8 hydrogens. So that one wouldn't work. But the 2 that we drew here are definitely structural isomers of each other. Okay, now there are different ways that we can draw these structural formulas. So expanded structural formulas are the ones we just drew on the last slide. They show all of the covalent bonds in the molecule. So down below you can see 4 different ways of depicting the molecule propane, which has 3 carbons and 8 hydrogens. So we have our Lewis structure, which shows all of the individual electrons. And then we have our structural formula, which shows covalent bonds as lines. But if you don't want to draw all of those individual bonds, you can also draw what's called a condensed structural formula. So that's shown down below here. And this is going to list all of the atoms in order, showing how they bond together. So if we look at our original structure, we have CH3 on the left-hand side. Then we have CH2 in the middle, and then another CH3 group on the end. And we can just kind of collapse all of those to say we have CH3, CH2, CH3. And then it's just understood that all of the carbons are attached to each other, and then the hydrogens are bonded to the carbon to their left. So that's another way to write it out, which can be much quicker. The last type of structural formula is called a line diagram or skeletal formula. And this is probably the simplest way to draw a molecule. So for propane, you can see the line diagram down below. It's literally just 2 lines at an angle to each other. And the idea here is that each vertice or endpoint is a carbon. So this endpoint is our yellow carbon, the middle point is our blue carbon, and then the other endpoint on the right is our purple carbon. And then hydrogen atoms are assumed. So we know that if a carbon only has 1 bond to another carbon, then the other 3 bonds are likely hydrogens. The carbon in the middle, the blue carbon, is bonded to two other carbons. So then we're going to assume that its two other bonds are hydrogens. So that's the easiest way to draw it, but we're probably going to focus on condensed formulas for now. So let's practice drawing condensed formulas. Let's draw the condensed structural formula for each of the expanded structural formulas below. And I encourage you to pause the video and try this on your own first, and then we'll go over it together. Okay, so let's highlight our groups. So on this molecule, we have a CH3 on either end. Okay, and then we have CH2. Let's see, we can use green next. I'm just going to highlight them different colors so we can kind of see where they end up. And then we have CH2 in the middle. Okay, so CH3, that'll be our blue carbon on the left-hand side. Next to that is our purple CH2. Then we have a green CH2. Then our yellow CH2, green CH2, purple CH2, and then blue CH3. Okay, and that kind of helps me just to visualize where everything is and how it's all going to collapse down. Now, you don't have to highlight or color things. If you want, another way to figure this out is just to count your carbons. So you can say, okay, I have 1, 2, 3, 4, 5, 6, 7. So I'm going to have a CH3 to start, and then 5 CH2s. And then the last carbon will be a CH3. That's another way to do it as well. Okay, so let's look down below. This one's a little different because it's a branched alkane. So it has a little branch coming off of it at the bottom. So we'll just highlight that branch. And then I'm just going to highlight because I like to, again, visualize what I'm doing. All right, so we've got those, and then CH2 groups. Okay. And then in the middle, we have a CH. All right. So I'm going to draw this off to the side. So let's see, we've got CH3, then we have our purple CH2, then we have a CH, followed by another CH2, and another CH3. So on that middle carbon, the CH, that's where we have our CH3. So you can draw it like that, where the CH3, the red one, is just kind of coming down off of that CH. Or another way to write this is with parentheses. So next to our CH, we can write CH3 in parentheses. And it's understood that the CH3 group is a branch. So it's coming off of the previous carbon. And then we'll just finish it up with CH2, CH3, and it's understood that the CH2 is also bonded to the previous carbon before the parentheses. All right, so two different ways to draw the condensed structural formula for a branched alkane. Okay, so next time, we're going to start discussing what are called functional groups. So these are just different combinations of atoms that show up regularly in different organic compounds. So I will see you then.